I noted that Mike Barker asked a question of Hannes, and Hannes responded with a paper reference. But if Hannes, if you have something you'd like to respond verbally to Mike, so he doesn't have to go read a whole paper, that'd be great. And if you have any other questions, please put them in the chat. Before Hannes speaks, I want to thank Ryan Watkins for being our diligent slide flipper during that last presentation, and also all of you for participating so well in the chat.
I think Mike should totally read my entire paper. So now what we did with the elephant height terrain, it's everywhere in the moon, right? It's ubiquitous. It's nothing special. What we just did is that we correlated with the slopes that we see it on, and also its less intense versions. I mean, there's real ropey elephant height terrain, and then there's stuff that's less intensely modified by whatever slope process that does form it. We still don't know really. Bottom line is, it neither looks different anywhere else than anywhere else on the moon, nor is the slope regimes that it occurs on and gets more or less intense on different from the limited studies that were done on that in other parts of the moon. Bottom line, it doesn't seem to be different around the South Pole than anywhere else on the moon. So that was an important take-home message from that part of the study.
Okay. Do anybody else have questions for our speakers, or questions in general about Connecting Ridge as a landing region? While people are contemplating their questions and formulating them, I will ask our people who spoke, and I know that Erwan had to leave for another meeting. So Mike Barker, if you want to volunteer to respond to some of these, that's as good as well. So all of you focused on Connecting Ridge. So given the studies that you did, some of you also talked about how your studies also kind of applied to other landing regions. Are there, putting on your kind of like NASA hat, if you will, are there landing sites that are more favorable for the kinds of studies that you spoke about, or less favorable? Or can you say anything about Connecting Ridge? I don't want to say advocate for it. You've all done that in your talks, but to talk more broadly about the regions, based on the things that you spoke about. I know that's kind of a broad question, but I'm kind of waiting to see if anybody else has questions in the chat or is willing to unmute and ask them vocally.
Yeah, I don't have anything profound to add about Connecting Ridge. I think it's a great site largely because, it has such great illumination, low slopes that allow you accessibility to various regions. And then I think the bonus of having the surface disrupted at a known time in the past is helpful to some of those other questions.
So one of the questions that I saw in the chat that went by, and I don't know if you fully answered or not, is how would you know whether material at any of these sites comes from Tycho?
Yeah, sorry. I think Dean Epler asked me a question. I think he might have only sent it to me and I answered to everyone or something.
Okay.
But yeah, so I think how would you know? It would be kind of analogy to understanding what is the age of Copernicus based on landing on its right at Apollo 12. And that wasn't, a slam dunk, but there's a generally accepted age of 800 million years there. So I think with an even younger site, you would be more likely in this case, certainly where, there's no Tycho material that's been found at Apollo 17, certainly more likely to find some, and you would build that up based on kind of glassy morphology and ages. I think actually some of the more interesting science, though, is not, at least from my perspective, is related to knowing that kind of resurfacing, looking at the process of resurfacing and gardening the regolith there, and then knowing that age of last major disturbance of the site.
Okay, there's a question here.
Quick question on the light. I'm sorry. I didn't mean a quick question on light. Do we know in that sort of local region the ultraviolet light measurements? We've been using ultraviolet light to cure 3D printed metals. So in other words, instead of having to haul a bunch of chemicals to cure the metals, You put it in the ultraviolet light, and boom, it's super solid. The molecules are great. It's beautiful. So you got a factory from that. If we know the measurements.
Well, I don't know that for sure. That's not my area of expertise, but sunlight's got a lot of UV and there's no atmosphere on the moon. So theoretically, putting it out in the sun will be pretty good for that sort of thing. But other people maybe can answer.
Yeah, I would think so. I just didn't know about the angle. So go. Thanks.
Yeah. There's a question in the chat I saw from Senator Schmidt about at these temperatures, ice particles will act like any other particles in the regolith. So it may not be surprising that PSRs look like the rest of the lunar surface. If any of our speakers would like to comment on that, please feel free to do so. Maybe that was for Hannes. He was talking about surface
I
textures.
already clarified in the chat that our mapping is a geomorphic mapping, and we don't have any, or at that point of time, without ShadowCam, of course, there were no data pertaining to the PSRs on and around the connecting ridge. So therefore, our analysis, all of our analysis, including elephant height investigation, pertains to the illuminated areas only. So we cannot assess yet the specifics about differences within PSRs or elsewhere on the moon, but just the illuminated areas of the connecting ridge. They look the same anywhere else on the moon pertaining to the elephant height.
All right, so I'll ask this question because it occurs to me. So, Prasanna, you've seen a lot of and been working with a lot of the ShadowCam data. Are you seeing different textures in those heavily shadowed areas, or does it look? If you ignore the fact that they're permanently shadowed, does it mostly look like other surface textures?
I'm sure there are people who look much more at ShadowCam data here than me. I just skimmed through it real briefly from a few images. For examel, those of Shackleton interior. At first, the first assessment is that the elephant height terrain, its occurrence and its specific setup doesn't strike me as drastically different. But this is just a very qualitative first order assessment. Like, we need people who do statistical analyses of these things.
Hey Ross, on this question. So yeah, I mean, if you look into the featured images that we have published so far, you can already see that a good part of it actually looks like the original moon. However, as we are kind of sharpening our pencils with respect to the calibration and everything, I think we'll have a better story to talk about the textures pretty soon. But this is actually quite too early because we have just started the mission.
Yeah, that makes a tremendous amount of sense. Let's see. Any other questions in the chat? I'm not seeing anything. Please, if you have questions, we still have time in this discussion section. Please unmute yourself and to ask.
I have a question, maybe. It's a
Sure.
more general question that could be answered in the chat, possibly. And of course, first-hand experience by former Apollo astronauts is most valuable in this sense, but specifically the usability of the field maps and specific caveats. I'm always interested in gathering all information I can get my hands on in that respect. So if anyone is aware of further reports or can relate any personal experience pertaining to that. So because it's one of the goals to produce a map that is as usable in the field as possible. And with that, I want to connect one final shout out I wasn't able to in the talk. The map we produce is not the final word. There's more and better data coming in all the time. Also, better data products. For example, the new NAC mosaics that are being produced. And they're already superior to the ones that we used. So it's a shout out to community to see this as an iterative and evolutionary process, and that not just because someone already mapped the connecting ridge now, it should not be done anymore. We can already go back and do it better, for example. So it should be an iterative process. Shout out to community. If people feel they can do it better, see other things, then they probably can.
Yep, that's a great sentiment. So I actually had a question for Erwan, but he's gone off. So I'm going to ask Mike Barker if he's willing to answer. In Erwan's presentation, he provided a bunch of views of maps of illumination for these different sites. I assume those are all based on the 5-meter LoLa data. One of the things that we found in our study for Viper, that as we push down to smaller length scales of terrain from stereo and shape from shading, that the kind of the regions that had a lot of illumination become, as one might expect, perhaps smaller and more fractured as you go down in scale. Can you tell us what you think? What we found is that, you know, we've only done a big study in the area for Viper, right? That LoLa is very indicative of what we might find at lower scales, right? The areas of good light or minimal darkness are smaller and become fractured as you go to smaller scales. But what LoLa tells us at 5 meters or at 20 meters is a good indicator of what we might find when we push further down. That was true, like I said, but that's only true I only know that's true at the one site that we studied for Viper. Do you also anticipate the characteristics in general, conclusions that you get at from the 5-meter data to apply as you push farther down, as these missions begin to do detailed surface traverses and planning for missions, et cetera? Or is there some limitation to how we should interpret, these larger scale conclusions from LoLa data?
So let's see. I'm not totally sure I understand what you're asking, but first, so the maps that Erwin presented, those are based on the new 20 meter per pixel map that's
20 meter, okay.
coming out soon. But in terms of like extrapolating the sort of illumination conditions to like below 5-meter scales and how much, so you're asking like how well do the LoLa maps kind of represent the illumination conditions at smaller scales?
Yeah, right. Like
Yeah.
how much can we use those larger scale data products to attempt to, rank or determine favorability as we then go down? So do we need to get all of the landing regions at 1 meter per pixel to make some of these assessments, or can we effectively, compare these sites at these larger scales, which are easier to process and think about?
That's a tough question. I would say, I mean, you have to keep in mind that the LoLa data density does vary throughout the polar region, especially as you move farther from the pole. And there are some, even longitudinally at the same latitude, there can be varying data density. And so, the ability of the LoLa DEMs to capture all that really small scale information varies a little bit. But I mean, I think overall in that sort of in the whole Artemis zone, it's pretty good at capturing that small scale information. So, I mean, I think we should always use, the data, all the data that we have to its, maximum extent possible. So I'm not sure that I would say, oh, don't make 1 meter per pixel maps for all the sites. I mean, I think that would be valuable to do as well, because we, as a community, we have the resources for doing that. So I would certainly say that's probably worth doing, and pooling our resources as much as possible, to kind of maximize what we know about those sub 5-meter scales, using like NAC images and whatnot. So.
Right.
Yeah, I'm not sure how well that answered your question.
No, it was kind of a rangy question anyway, and I thank you for attempting a stab at it. Jim, I see your finger up.
Yeah, just a quick comment on that. On Apollo 15, we landed in 20-meter resolution images, okay? And, I'm not proud of that, but that's all we had at the time. We knew 11 and 12 Mari textures. We had slow 4, lunar orbiter data. But the key part was that, we had humans landing the thing, and we knew the terrain pretty well. So that's not the case. Okay, so don't get your hopes up here. That's not the case for the highlands. The highlands are so diverse. And with the elephant hide terrain and variations in slopes, I don't think we know enough to be confident that 5 meters is going to extrapolate down to 1 meter. And I think we just need the best data we can get. Exactly. Despite that 20-meter resolution, don't let that convince you that in the highlands the same thing's going to be part. Yeah. Thanks. Sorry.
Right. Thank you, Jim. Dean, I see your hand is up. Oh, but you're muted, perhaps. still muted, I think.
Relative, sorry about that. Relative to Hannes's question on Apollo 17, I thought it was amusing or interesting that he used the Apollo 16 map because, of course, we had an idea of what we were going to find there, and it turned out to be completely wrong. Not because the mappers were bad, but just because, our level of ignorance at the time the map was done. Apollo 16 was successful because the crew was trained very well in geologic, interpretation and geologic description. So they just kind of said, well, that's not what we see, but here's what we do see. And, went and did their job. So one, it argues for good training. Again, the Apollo methodology is probably still applicable here, and that is you do your best geomorphically, you use that to drive where your traversers go, you train your crew really well, and then you turn them loose on the terrain and let them go see what they see rather than what you think they should see.
That's a great point, and probably a good one to end on here, as we are out of time for our discussion section.